Suppose you had a Bible, very valuable Bible, and somebody asks you for a copy of the Bible. So what you do is you say, well, I can't give you the Bible, but what I can do is I'll photocopy the pages. Now, it's a long process, of course, so what you do is you start photocopying the pages. You take each page and you fold it up and you put it in an envelope and you address it to the person and you put it in the out tray. And you keep doing that as you photocopy the pages. Postboy comes by, collects what's in the out tray, takes it down to the post room, and it disappears into the postal system. Meanwhile, you're still copying the Bible page by page and you're sending it off one page at a time in the envelopes. The guy at the other end, receiving the envelopes, not necessarily in the same order that you sent them, opens the envelope, takes out the page, looks at the page number, reassembles the Bible in the correct order, and now he's got a photocopied version of the Bible. And of course the postal system in the middle didn't have to carry a whacking great precious Bible. What it carried was little pieces of the Bible, chunk by chunk, packet by packet. That's what packet switching is. You take your original data stream or your data set and you chop it up into small pieces, you transmit that through the network. Each piece is separately addressed, finds its own way through the network, recipient gets it, puts it back together into the original block or stream or whatever. That's basically what it is. That's what it is. Why do you do that? It's to do with queuing. If you have packets arriving and they're all little pieces, then you can very quickly sort them and send them on their way. But if you've got a whacking great message that's stuck being transmitted down the line, then you've got to wait for that to finish before anything else can happen.
And it was interesting that Donald Davis, who started all this, observed that in the same way that large mainframe computers sliced up their programs for the benefit of the operators, why couldn't we slice up the communication mechanism between the terminal and the computer in much the same way, and basically for the same sort of reasons? Because what you needed to do when operating these programs every so often was to put in a very short message, which was a command or something. And there was a real danger that if you use the telephone line in the traditional way, that this command would be delayed because there was a long message on the line. So the origins of packet switching were really rather similar to the way that the batch processing mechanism developed, in that the communication network was sliced up in much the same way in packets.
When Donald Davis first mooted the idea, his first paper was internally published 1965, when it was actually published, and he, one of his two lieutenants, a man called Derek Barber, who was my boss, and they discussed setting up a small research group, which they did. And so Derek came to me and said, I want you to lead this small group, and you can have 2 people to work for you. He's one of them, so Keith Bartlett. The other is Peter Wilkinson, Dr. Peter Wilkinson, who was our software expert. And so between the 3 of us, we started to just put flesh on the bones to try and work out how you would design such a system. And then when we got to a certain point where we were able to publish the work, Donald was able to appropriate funds to allow us to expand the team, and then we got some other guys in, like this guy here, to work on actually building the network and deploying it as a service. When we first started, we were just going to build something to make it work, to show that it could work. So it was very much just going to be a straw man system. But fairly quickly, I think Donald realised that in order for it to have any impact, it needed to be a proper working system. And we actually built the network, and it went live in service, I think, at the beginning of 1970.
The finger was pointed at me to write the software, which wasn't a problem, because I mean that was my role, and I sort of accepted the challenge. But I went away from that meeting feeling a little bit pretty nervous, because I mean, nobody, as far as I know, had ever written anything like that before. It's all completely new. And where do you start? So the decision was taken fairly early on that we'd have to write software for the bare machine. No, just using the assembler, no support from Honeywell pre-existing software whatsoever.
I think when he first ran it, there were 2 bugs.
I don't remember those. I was, having been responsible for the hardware, I was furious because his software worked first time.
Or very nearly.
And one of the key inputs for me was a paper which I got via Mike Woodger by Edgar Dijkstra, who was sort of one of the gods of computing science, called Cooperating Sequential Processes. And that gave me one of the key ideas that what I needed to do was to structure the software in the computer to sort of mirror the outside world where lots of independent things were going on by means of a collection of processes within the computer software.
The beauty of the NPL site was that it was a multidisciplinary site. So the network did 2 things. It served the needs of the laboratory in order to enable the scientists and engineers to get access to the computers, but it also tested out the ideas of packet switching. And it tested out the ideas of packet switching under a realistic situation.
There was another service that had been pioneered by another team, and they'd come up with something called Scrapbook, which was an information retrieval system. Once they connected that to our new network, all the scientists could type their papers directly in via a teletype or a visual display unit and get it recalled instantly.
And that was absolutely true. So this was an information system, a server, although we didn't have the name at the time, we called them the server.
Yeah.
It was a server where you could put in information. You could edit the text, so it was a bit like a word processor in a sense. But then people started sending messages to each other because you could exchange information, because you could look at somebody else's file, so you could actually exchange. It became an email system, although we didn't call it email at the time, and a data repository. But sorry, the interesting thing I was going to say was, because people started typing their own papers, the need for typists to cut, carbons and do all of that sort of stuff just disappeared.
Yes.
I got told off for typing in my own reports. The Human Resources Department, it wasn't called that then, but they were very concerned that the typists and the secretaries were being underused, and I had no business typing my own reports into a computer.
So the network was multi-user and multidiscipline, and that was a fortunate situation for us to be able to take the ideas and build something and actually use it. The other thing we ought to say about this is that when we first put the network together, we decided that speed, because this is a network site that was owned entirely by the NPL, we weren't constrained to use telephone wires. So we put in high capacity links everywhere, and even every single user who had a terminal had a 1 megabit per second link. And of course at that time people were going, that's crazy. You know, you've got a typewriter and you've got 1.5 megabit link. Well, if you think now, of course, that most people have 2 or maybe 8 megabits coming into their home, it isn't a silly idea, but at the time it was regarded as being rather strange. Spread out from building 93 to cover eventually more or less every building in the laboratory.
Yes.
By the beginning of the 60s, the telephone networks around the world, particularly in the USA, I guess, had become very big. There were millions of telephones in service using the technology of the day, which is an analog circuit switch technology. And we were coming along suggesting something quite fundamentally different for computers. and there was resistance to that idea simply because it didn't fit with what was already deployed in the ground. And the idea of using very fast lines for terminals was something which was anathema, because they were used to using very slow lines for telephones.
Post office telecoms, and they got their business market set on, what is it, 4 kilobit lines for voice, and along come these bunch of guys who know nothing at all about telecommunications. But we had no baggage because we didn't know anything about telecoms. We had absolutely no baggage, so we just started from scratch and said, this is a system that will work.
And one of Donald's great assets was that he knew the politics. He was very aware of the politics, and he trod very carefully with the post office. And to their credit, there were people in the post office who gave him a hearing.
The first time that one of our American friends came over from ARPA to visit us, and I showed him, I'd got a VDU unit, glass screen keyboard unit, and I connected up the scrapbook, and I hit the button, and the whole page appears in less than half a second to get a whole page up. And he was just gobsmacked, because he was used to seeing the stuff crawling onto the screen like this at a few hundred characters a second. The ARPA project was just starting at the same time, and the network to connect those computers together was something they were only just about considering. Now, their idea was to use fairly low speed lines, because that's all that was available from the telephone company. So when our paper, which was actually published in the same session as their paper, said, no, don't do any of that slow telephone stuff, use 1.5 megabits. And they were going, oh yeah. But within about a year, they had designed a system. It was actually built by a company called Bolt, Baranek and Newman, and they had designed a system. And if you look at their original designs and you look at our network paper and you go, I think they probably copied what we did. ARPA network at that time was 3 or 4 nodes, but if you look at the ARPA map of about 5 or 6 years later, it's got like 50 nodes on it. I mean, it covered the whole of US, but it was also extended to Europe, and Peter Kirstein's group at University College London had a connection to the ARPA network, and we got a connection to his interface and to our network. So we were then connected. So we had the first situation where 2 networks were connected, and there was inter-network traffic.
Yes.
Between the networks. And the idea of the computers connected together became the idea of an internetwork, which eventually became an internet, which eventually became the internet, and everything flowed from there. But of course the thing we have to remember is that the underlying technology for all of this is packet switching.
Yeah.
Anybody who has at home has got a router connecting to their broadband internet service and has more than one computer sharing that hub is using Ethernet, and that little hub that they've got is a packet switch, and in fact what they've got in their home is a microcosm of what we built at NPL. It's always gratifying, of course, when something you do like that works and is then taken up, but I don't think we had any doubt that what we were doing was absolutely right.
Oh no, none at all.
In one sense, things have come full circle. When Donald originally came up with the idea of packet switching, there were good, sound technical reasons for it. One of the most important was that people using telephone lines to communicate between computers and terminals. And telephone lines were designed for speech. And speech demands a time base. And Donald's realisation was that computers don't want a time base. The information that you give to and from computers is bursty, and it doesn't matter what time it's spread over. And as the technology developed, and as the networks developed, and as the bandwidth increased, what was essentially a data communications network has become used for more and more things. And now we are using it to transfer time-based information like telephony and television and pictures.
For some reason we decided we wanted to try out a piece of kit that had been lent to us by our colleagues at RSRE Malvern, and they had designed this digital speech encoder, codec it's called, which allows you to turn speech into a digital stream, and actually a quite compressed digital stream, which you can then send through a digital connection, and then you turn it back into speech at the far end. And we thought, why don't we try that on the network? Now the network has got this packet switch in the middle, so you're putting stuff into a packet switch and it's going through and coming out the other side. And we connected a couple of these codecs up we got from RSRE, and lo and behold we could actually send speech over our data network. Now this was 1970 something or rather, so this was an example of using a data network for carrying speech, which is a complete reversal of the roles now, because we were fighting the battle to send data over what had previously been bits belonging to the telephone network, and now of course we were able to show that we could send speech over a digital network that had nothing to do with the telephone network. And now of course you look around and you find voice over IP. Anybody use Skype? I mean,
yes,
that's exactly what you're doing. You are sending speech over a digital network. Now we did that in the 1970s.
Yeah.
It was a thing I look back on with greatest pleasure in my life, really. I think, it was just good guys to work with, exciting stuff, ploughing new furrow. It was just fantastic.
Whenever I see people saying, "Oh, I've got my ADSL link. I've now got a megabit download link, or 3 megabit download link, or whatever," because your upload speed's going to be a bit slower than that. And I can get onto computers on the far side of the world and go, "Yep, it works, doesn't it?" We've been doing that for 40 years.
Part of the day job, isn't it?
Yeah. Absolutely.
Being naive is a great advantage. I mean, I think other people have made us at similar points, but because we had no sort of baggage, it was we could just plough on with it and learn the hard way.
And 40 years later, Donald wrote in an annex to a paper, his final paper actually, he was thinking back to the hardware of the NPL network, and his comment was, "It was strange, but it served our purpose."